Imagine the sensation of a tall glass of milk pulled straight from the back of a refrigerator. It is heavy, impossibly cold, and the condensation on the glass leaves a slick, biting chill against your palm. When you take that first swallow, it has a specific, velvety weight, a coating that lingers on your tongue with a faint, fatty sweetness. It feels wholesome, a fundamental building block of the human diet that we've accepted as a universal truth. But as that cold liquid slides down your throat, have you ever stopped to wonder why that specific sensation belongs almost exclusively to one single animal? Why is it that when we say the word milk, our brains immediately conjure the image of a black and white Holstein cow, rather than any of the other 5,400 species of mammals currently roaming the earth? Why aren't you pouring a bowl of cereal drenched in pig's milk, or ordering a latte made with the rich, concentrated cream of a mountain goat or a water buffalo? Why did we collectively decide that the secretions of a multi-ton, four-stomached bovine were the only acceptable version of this biological fluid for a global civilization? And perhaps most importantly, if we could drink the others, what would that choice actually do to our bodies, our history, and the very chemistry of our food? These questions aren't just about culinary preference. They are a gateway into a bizarre intersection of evolutionary biology and accidental history. When you look at the sheer variety of mammalian life, you realize that milk is not a singular substance at all, but rather a highly specialized survival kit, custom-tailored for the specific needs of a specific infant. For instance, and this is a detail that usually ruins people's appetites, have you considered why we don't milk pigs? Pigs are highly productive, they have a dozen or more teats, and they are already a staple of our agricultural system. Yet, you will never find pig cheese at a high-end deli. Why is that? Or consider the horse. We've lived alongside horses for millennia, and while some cultures in Central Asia have a rich tradition of fermenting mare's milk, it has never gained a foothold in the global West. What is it about the chemistry of a cow that made it the undisputed champion of the dairy aisle, while nearly every other creature on the planet was relegated to the do not consume list? To answer that, we have to look at the dairy matrix, a term researchers use to describe the complex structure of fats, proteins, and minerals that make up different milks. In a 2011 study led by Dr. Arnie Astrup, researchers began to realize that the physical structure of milk, the way the fat globules are encased in a specific membrane, actually dictates how our bodies process the nutrients. Cow's milk happens to have a very specific ratio of casein to whey proteins, roughly 80% to 20%, which makes it remarkably stable for transport and processing. Which, if you're a 19th century milkman, is the difference between a profitable business and a wagon full of spoiled sludge. But if you look at a hooded seal, the composition shifts into the realm of the absurd. A seal pup needs to survive in sub-zero temperatures, so its mother produces milk that is nearly 60% fat. It doesn't look like a liquid, it has the consistency of toothpaste or heavy caulking. If you tried to pour seal milk into your coffee, it wouldn't dissolve. It would sit there like a lump of warm lard. So, is the cow just a lucky biological middle ground, or is there something more calculated about our choice? The mystery of why we don't drink pig milk is actually a perfect case study in the logistical nightmares of dairy. Pigs are notoriously difficult to milk, not just because they lack the large storage cisterns found in a cow's udder, but because they are physically aggressive during the process. While a cow might stand stoically for an hour, a sow becomes extremely defensive and can only let down her milk for about 15 seconds at a time. Imagine a farmer trying to squeeze enough milk for a single gallon from a creature that wants to take his hand off every 15 seconds. Furthermore, the taste of pig milk is often described as gamey and watery, lacking the smooth mouthfeel that we've been conditioned to crave. But this leads us to a deeper question. If it's not just about the taste or the difficulty of the harvest, is there an evolutionary reason why some populations can drink any milk at all while others are physically punished for trying? This brings us to one of the most significant genetic glitches in human history. About 10,000 years ago, humans were almost entirely lactose intolerant as adults. We were like every other mammal. Once we were weaned off our mother's milk, the gene that produced the enzyme lactase simply switched off. Drinking milk as an adult meant immediate, violent digestive distress. However, a study published in 2007 by Mark Thomas and his colleagues used DNA from Neolithic European skeletons to prove that a specific mutation occurred in the regions of modern-day Hungary and Austria. This mutation kept the lactase gene on throughout adulthood. It was a biological superpower that allowed a starving population to extract calories from their livestock without killing the animals. But why did this happen primarily with cattle? Why didn't we see a similar boom in rat milk tolerance or deer milk tolerance? The answer lies in the ancestor of the modern cow, the auroch. These were massive, terrifying wild oxen that stood 6 feet tall at the shoulder with forward curving horns. They were dangerous, but they were also incredibly efficient bioreactors. An auroch could eat grass, a substance humans cannot digest, and turn it into high-quality protein and fat. When humans managed to domesticate these beasts, they didn't just get a source of meat, they got a mobile, self-replicating nutrition factory. Over thousands of years of selective breeding, we took the auroch and turned it into the Holstein, an animal so specialized for milk production that a single cow can now produce over 10,000 liters of milk a year, which, when you think about it, is a staggering physiological feat that borders on the unnatural. If you tried to get that kind of volume from a goat, you would need 20 goats for every one cow, and each of those goats would require its own space, its own health care, and its own stubborn management. Is our preference for cow's milk just a result of us being lazy accountants? But let's talk about the exceptions, because they reveal even more about the why of our dairy choices. In the high altitudes of the Tibetan Plateau, the yak is king. Yak milk is nearly twice as fatty as cow's milk, which is essential for survival in thin, freezing air. In the deserts of the Middle East, camel milk is a staple because camels can produce milk in conditions that would kill a cow in days. Camel milk also contains 3 times more vitamin C than cow's milk and doesn't curdle as easily in the heat, which makes it a perfect desert survival ration, provided you can handle the slightly salty aftertaste. So if these milks are so nutritionally dense, why haven't they gone global? Why can't you buy camel yogurt at a supermarket in Ohio? The answer comes down to scalability and a historical accident called European colonialism. As European powers expanded across the globe in the 15th through 19th centuries, they brought their agricultural systems with them. The cow was the engine of the European farm, and so the cow became the engine of the global food system. We didn't choose cow's milk because it was the best milk. We chose it because the people with the biggest navies happened to be cow people. They displaced indigenous dairy traditions, like the use of llama milk in the Andes or the consumption of water buffalo milk in Southeast Asia, and replaced them with a standardized, bovine-centric model. A model that, interestingly enough, is now being challenged by the rise of plant-based milks, which are essentially trying to mimic the very mouthfeel and chemistry we spent 10,000 years breeding into the cow. But if we look even further afield, into the realm of the truly strange, we find milks that defy everything we think we know about nursing. Have you ever heard of pigeon milk? It sounds like a joke, but it's a biological reality. Both male and female pigeons produce a substance called crop milk in their throats to feed their chicks. It's a semi-solid, yellowish, cheese-like substance that is incredibly high in protein and fat. Though I doubt anyone is rushing to market a pigeon milk latte anytime soon. Then there is the platypus. Because the platypus is a monotreme, it doesn't have teats. Instead, the mother sweets milk from mammary glands onto her stomach, and the babies lap it up from her fur. This milk contains a unique protein with powerful antibacterial properties, which scientists are now studying to fight superbugs. It turns out that sweating your milk onto a dirty swamp floor requires some pretty intense chemical protection. And then there is the most nutritious milk on the planet, which doesn't even come from a mammal. The Pacific beetle cockroach, Diploptera punctata, gives birth to live young and feeds them a liquid that crystallizes in their guts. These crystals are estimated to contain 4 times the energy of cow's milk. Now, and I realize the mental image of milking a cockroach is horrifying. This brings us back to the central question. Why don't we drink these other milks? Beyond the obvious logistics of trying to find a stool small enough to milk a cockroach, there is the issue of rennet. Most of the dairy we consume isn't liquid, it's cheese. And cheese requires a specific chemical reaction to turn liquid milk into a solid. Cow, goat, and sheep milk all react predictably to rennet, an enzyme found in the stomachs of young ruminants. Camel milk, however, is notoriously difficult to turn into cheese because its proteins are structured differently. For centuries, it was considered impossible to make camel cheese on a commercial scale. It wasn't until the 1980s when a scientist named Dr. J.P. Ramet developed a specific enzymatic process that the first stable camel cheese was produced. If an animal's milk can't be easily turned into cheese or butter, it loses its value as a storable, tradable commodity, which effectively disqualifies it from the global market. But there is another layer to this, one that involves the very temperament of the animals themselves. To have a dairy industry, you need an animal that is willing to be handled, touched, and manipulated by humans on a daily basis. This is where many potential candidates fail. Take the moose, for example. In Russia, there is a famous experimental farm called the Kostroma Moose Farm that has been trying to domesticate moose for dairy production since the 1960s. Moose milk is incredibly rich, with high levels of lysozyme, which gives it a long shelf life and medicinal properties. The researchers actually use it to treat gastrointestinal diseases. However, moose are solitary, flighty, and incredibly sensitive. They don't herd like cows. If you stress a moose out, she simply won't produce milk. They require a level of individual attention that makes large-scale farming an economic nightmare. You can't just put a moose in a milking parlor and expect results. The same problem applies to the zebra. You might wonder why, since we milk horses and donkeys, we don't milk zebras. They are closely related, after all. But zebras are the angry cousins of the equine family. They evolved in an environment full of lions and hyenas, making them hyper-reactive and prone to biting and kicking with lethal force. Which is why, despite numerous attempts by colonialists to break zebras like horses, they remain largely undomesticated. If you can't domesticate the animal, you can't milk the animal. It's as simple as that. Our entire dairy culture is built on the backs of the few animals that were polite enough to let us steal their offspring's food. We have filtered the thousands of milks available in nature through a narrow sieve of temperament, scalability, and historical luck. So, when we look at the modern dairy aisle, we aren't seeing a list of the best biological options. We are seeing the survivors of a 10,000-year war of attrition. We are seeing the results of the Aurochs' docility, the Holstein's sheer volume, and the European Navy's reach. We drink cow's milk because it is the most efficient, most portable, and most cooperative liquid protein on the planet. But as we move into an era of synthetic biology, where we can now produce cow milk in a lab using yeast and fermentation without ever touching an actual cow, the definition of milk is shifting again. We are finally separating the matrix from the animal. We are finding ways to recreate that specific velvety sensation without the multi-ton animal, the methane emissions, or the logistical nightmare of milking a grumpy sow or a flighty moose. But what if we had taken a different path? What if the first humans to develop lactase persistence hadn't been in Europe, but in the subarctic? Would we all be drinking reindeer milk today? Reindeer milk is 22% fat, essentially liquid cream. If our entire global food culture had been built on that level of caloric density, the very shape of our bodies and the structure of our recipes would be unrecognizable. Our default would be a thick, heavy concentrate that would make a modern milkshake look like water. Instead, we have the cow, a middle-of-the-road, reliable, and slightly boring biological miracle that has shaped our skeletons and our economies. Is it possible that we are missing out? Some researchers argue that the A1 protein found in most modern cow's milk is actually more difficult for the human gut to process than the A2 protein found in goat, sheep, and older breeds of cattle, a theory that has led to a massive surge in A2 milk marketing in recent years. We are beginning to realize that the one-size-fits-all approach to dairy might have been a mistake. We are seeing a return to heritage milks, buffalo, goat, and sheep, as people look for a dairy experience that feels more compatible with their specific biology. We are rediscovering the nuances of the milks we left behind in our rush to build an industrial milk machine. The question of, why don't we drink other animals' milk, isn't just a curiosity, it's a mirror. It reflects our history of domestication, our genetic evolution, and our tendency to prioritize convenience and scale over biological diversity. Every time you reach for that carton in the grocery store, you are participating in a tradition that was forged in the fires of the Neolithic Revolution and hardened by centuries of global trade. You are drinking a substance that was literally engineered over millennia to be the perfect companion to the human diet. But the more we learn about the chemistry of other creatures, from the supermilk of the platypus to the toothpaste fat of the seal, the more we realize that our current dairy landscape is just one tiny, accidental slice of a much larger, stranger biological world. The diversity of milk is a testament to the creativity of evolution. Every species has solved the problem of how to grow an infant in a different way. Some solved it with fat, some with sugar, and some with complex proteins that act like natural antibiotics. And some, like the kangaroo, solved it by producing two different types of milk at the same time from different teats to feed joeys of different ages. We have chosen to ignore 99% of that creativity in favor of the cow. It was a choice of necessity, then a choice of habit, and now it is a choice of industry. But as technology advances, the why of our dairy choices is becoming less about what an animal can provide and more about what we can imagine. We are entering a period where the physical sensation of milk, the cold, the weight, the sweetness, can be divorced from the animal entirely. We are no longer limited by the temperament of a moose or the aggression of a pig. We can design the dairy matrix from the ground up. Which means the next time someone asks why we don't drink other animals' milk, the answer might be because we finally figured out how to make something better than all of them combined. But even as we move toward a lab-grown future, the history of the cow remains written in our DNA. We are the milk-drinking apes, a species that hacked its own biology to survive on the secretions of another. We are a biological anomaly, a creature that refused to grow up and stop nursing. Consider the complexity of a single drop of milk. It is a suspension of fat globules, an array of proteins, a source of minerals, and a carrier of hormonal signals. It is the first thing we experience in this world, and for many of us, it is a constant companion until the end. We have built entire civilizations around the management of this fluid. We have fought wars over pasture land. We have mapped the human genome to understand its effects, and yet, for all our science and all our history, we still find ourselves coming back to that simple physical sensation of a cold glass of milk. It is a primal comfort, a biological anchor in a chaotic world, but why the cow? Ultimately, the cow was simply the animal that was there when we needed it most. It was the animal that could survive the European winters, the animal that didn't kick too hard, and the animal that produced just enough to feed a village. The cow is the default, not because it is the best, but because it is the survivor. It is the biological winner of a game it didn't even know it was playing. And as we look toward the future, we have to ask ourselves, are we okay with that accident? Are we satisfied with the default, or are we ready to explore the vast, fatty, salty, and gamey world of the milks we left behind? The history of milk is a history of us. It is the story of how we moved from being a part of the natural world to being the managers of it. It is the story of how we took a biological survival kit and turned it into a global commodity. A commodity that, for all its industrial polish, still bears the unmistakable marks of its wild ancestors. We are the only species that drinks the milk of another species into adulthood. We are the only species that has turned nursing into an industry. We are the dairy apes. And our choice of the cow is the most successful, most profitable, and most unlikely accident in the history of our species. So the next time you feel that cold glass in your hand, don't just think about the farm or the carton. Think about the auroch. Think about the Neolithic farmer in a cold Hungarian hut who didn't get sick after drinking a bowl of fresh cream. Think about the colonial ships carrying cattle across the Atlantic. Think about the dairy matrix and the fat globules that are currently sliding down your throat. You aren't just drinking a beverage, you are drinking a 10,000-year-old survival strategy. You are consuming the result of a massive, accidental experiment in co-evolution. And that is a realization that should make the next swallow taste a little bit different, because in the end, it's not just about the milk. It's about the fact that we were willing to change our very DNA just to keep a taste of it. We are the creatures who refused to let go of the breast, who looked at a 6-foot-tall wild ox and saw a meal that could last a lifetime. We are the architects of a bovine world, and every cold, creamy sip is a reminder of how far we were willing to go to stay fed. We are the masters of the cow, but in a very real way, the cow has become the master of us. Our cities, our diets, and our very genes are built around her. And that is a debt that we can never truly repay, no matter how much milk we drink. Think back to that sensation from the beginning, the biting chill of the glass, the velvet weight on your tongue, the lingering sweetness. That feeling isn't a gift of nature. It is a meticulously crafted evolutionary heist. You are feeling the exact caloric reward that a 1,000-pound herbivore designed to turn a helpless calf into a powerhouse, but you have intercepted it. That specific, heavy coating on your tongue is the result of 10,000 years of humans selectively breeding a wild beast into a biological machine that produces a surplus so vast it can drown a planet. When you swallow, you aren't just taking in nutrients. You are participating in a cold, calculated survival pact that allowed our ancestors to endure while others starved. That refreshing sweetness is actually the taste of a biological monopoly, a reminder that we have terraformed the animal kingdom to suit our cravings. It is a chilling realization that your very comfort is built on the systematic redirection of another creature's life force. You are drinking the success of a mutation, the legacy of a colonial machine, and the ultimate victory of the cow over every other mammal on Earth. So take one last look at that glass and realize that the sensation you love is the definitive closing argument for our dominance over the natural world. Now that you know the true cost of that creamy texture, does it still taste like a simple glass of milk, or does it taste like the spoils of a 10,000-year war? If this deep dive into the hidden chemistry of your fridge changed how you see your breakfast, subscribe for more investigations into the weird ways we've hacked our world. What other default food do you want us to dismantle next? Let us know in the comments.